So in this video we'll be going through everything related to cumulative frequency diagrams, and including that will be how to calculate the cumulative frequency values, how to plot the various types of cumulative frequency diagrams you could get asked to draw, how to read information such as the quartiles, the median and values that are less than more than from a cumulative frequency diagram, and also how to draw a box and whisker diagram from a cumulative frequency diagram. So before we go on to show you how to calculate the cumulative frequency values and how we go about drawing a cumulative frequency diagram, let's first of all introduce what one is. So a cumulative frequency diagram is a statistical diagram typically used to represent the rate of increase in frequency of group data. From this diagram we can produce mathematical estimations of the type of calculations that will be easy to find had the data not been grouped, such as being able to find the median, find the quartiles, finding an amount that's less or more than a particular value. Now it can also be used to draw a box and whisker diagram, see a previous video if you're not sure what box and whisker diagram is, which can only be drawn with once you have raw data or a list of numbers in the data set. Now the word cumulative means a running total. So being asked to calculate the cumulative frequency means you need to write down the running total of the frequencies as you go up through the groups. So calculating the cumulative frequency values, so most often you'll be given a grouped data frequency table and you'll be asked to calculate the cumulative frequency values, and this is basically asking you in the whole set of data how many are less than the upper bound of the group class band. Now if you're not too sure what I mean by that, do not worry, I will explain when we have an example which we'll move on to now. So for example, the frequency table below gives the lengths in millimeters of 150 leaves. The shortest leaf is 80 millimeters and the longest leaf is 195 millimeters long. By calculating the cumulative frequency, draw a cumulative frequency diagram to represent the data. So this is typically what you'd be given in a exam or in a question, and you need to work out what the cumulative frequency values are. So the first thing we need to do is create a cumulative frequency column. Now what the cumulative frequency values are, now if I look at the upper bound, so in this we're looking at 100, so from this 150 bits of data, how many are less than 100? And that would be 6. The next question then says how many are less than 120? Well, I've got 16 that's in between 100 and 120, but I've also got the previous 6. So in terms of how many are less than 120, well that's going to be 22. The next one is how many are less than 130, so I need to add, basically I need to add this value in the frequency with the previous cumulative frequency value. So here I'm going to end up with 49. How many are less than 135? Well that's going to be 69. How many are less than 140? Well that's going to be 86. How many are less than 150? Well that's going to be 8, and then add the 30 and we get 118. How many are less than 160? And that's, so we're going to add 16 to that, so that's then going to become 134. How many are less than 180? Well that's going to be 146. And then how many are less than 180? And that's going to be 100, oh should I say, yeah, less than or greater than 180, and that is going to be 150. Now what you should find is that your very last value should be the total, which kind of makes sense. It's like saying how many numbers on a die are 6 or less. Well that's going to be all of them because 6 is the maximum. So in terms of the cumulative frequency values, all you're doing is adding these numbers up. Now if I just highlight this 49 here and what that represents in terms of highlighting it in, let's say this one here, so let's just get rid of that, it's not as confusing. So basically what this number 49 represents is how many out of the 150 are less than 130. And again it's not going to be 27 because I need to add all the other two groups are also less than 130, so you need to add those along, and if you add them all up you're going to get 49. So let's now move on to, so once you've got your cumulative frequency values, we now need to go about plotting it. So let's have a look at how we do this. Now before we do that, what we need to discuss is the types of cumulative frequency diagrams you could probably be presented with at the level that you're working with. Now when presented with a set of data, typically in the form of a table, and you've calculated the cumulative frequency values, you could be asked to represent the data potentially in one or two common cumulative frequency diagrams. Now the first one, which is the most common, is a cumulative frequency diagram, hence no altercation in the name. And what you need to do there is plot the cumulative frequency values at the upper bound of the group and join the points with a smooth continuous curve. And that is the key thing, is joining the points with a smooth continuous curve. Now you might get asked to do a cumulative frequency polygon, which is where we plot the points in the exact same place, but this time what we do is we plot the points joining them up with straight lines. Now there is a third option, which is a cumulative frequency step polygon, which is slightly different and now kind of become a little bit more obsolete. So I won't go through this in this particular video, because I'd say the more often than not you're going to get asked to do one of these two. And the key thing to look out for in the question is basically this word here, polygon. If it mentions the word polygon, all it means is that you then have to join your points up with straight lines. So once we've plotted the values, now in terms of, as you can see, I've got some points plotted. Now what I've done, if I go back to the table, is I'm going to plot, if I just get rid of this circle and just get rid of all of that, and let's have a look at what we're actually going to plot what against what. Now my x ordinates I'm going to be plotting at the upper value. Now it'd be very tempting to plot at the midpoint or maybe at the minimum value, but what you will find is the fact that this is going to be your x ordinate. So if I just scroll down to these points here, you can see that each of the points are at those upper levels, and there's a few that are in between, and we've got one there, yeah, and one there at 195. Now where it comes to plotting, if I just go back to the previous part, is that it does mention that the smallest leaf that we've got is 180 and the largest is 195. Now if that information is not given to you, then generally speaking what you will find is that the graph should always start at 0, and again I'll go back when I get this, and the maximum point is going to stop at 195, and that's a pretty poor quality, so let's just go over that in green. So it's going to be from 180 to 195. Now again, if it wasn't, I would go up in the sort of groups. I would say 190 and just kind of use your common sense as to what you should go up to. So let's go back to the actual diagram. Now the other key thing you need to note is that you are also plotting against the cumulative frequency. So this is your CF value, and the values that go along the x-axis is always the numbers in the first column. So in other words, the group data. And there we go. Now this is the tricky part, is now joining the points up with a smooth curve. Now in this we're going to do a cumulative frequency diagram, and again let's just see how this goes. Now my minimum point, it says 100 is 80 millimeters, and my highest one is 195. Now when you are drawing a cumulative frequency diagram, there's a couple of things that you need to note. Your curve has to be continuous, so no gaps. Your cumulative frequency diagram should never go down. It should always, at worst, it should always stay flat, if not going up. And your line has to go through all the points. Now this is the tricky thing, and again I'm going to kind of shoot myself in the foot, particularly going through. Oh, let's try that again. Let's go for the direction. So you need to make sure that your line goes through all your plotted points, and there we go. And because the minimum point is at 80, I'm going to join those points up like so. Now that's not too bad, and you can see that we've completed our cumulative frequency diagram. You can see that I've joined them up with smooth curves, and it's going through all the points, and that the lines start at 0 at the minimum point, and again, which is 80, and it hits its peak at 150, and that's the top value. Now if I was to get rid of this, and let's say I was asked to draw a cumulative frequency polygon, I would plot the points in the exact same way, but instead what I would do is I would, and again, let me just get a finer pen, I would join these points up with straight lines. So what you do is with a ruler is you would join these points up with straight lines, which I'm not doing because it's difficult to use a ruler on this, and like so. Now you can see there's not much variation between the curve and the polygon, only because I've done it freehand and I've not used a ruler. So what you'll find is that your diagram should look something like that, which again looks like a curve. So not saying a very good example. Let's try again. Let's try into shape. Let's see if this proves to be a little bit more. And so it should look something like that. So just look out for the word polygon when you're doing your cumulative frequency diagram. Now the next, now that's probably up to foundation level or a medium sort of Key Stage 3 level. Now where it starts to extend is, like we mentioned in the introduction, that we use the cumulative frequency values to find values that we will typically find when we've got raw data. Now obviously if our data is grouped, the only way we can find those values is by, let's say, drawing a cumulative frequency diagram or by using quite a sophisticated calculator. So now I'm going to put these notes in the as an attached document, so obviously, or you can pause the video and make a note of these points, and I'll just talk you through. Now if it doesn't make any sense, do not worry, because I'm going to go through an example question where we go through this. So to find the median, the quartiles, and less than or more than values, which is like the part C, part D parts of a question, it is important that first, to find the median and the quartiles and any other percentage based value, you must use the total frequency value, not the highest value on the scale. Now what that basically means is that sometimes, for example, as you can see here, my largest value is at 195. Now it isn't at 200, so I've got to make sure that I'm using the highest possible number. And likewise, if my scale went up to 160, then it wouldn't be 160, it would be whatever the cumulative frequency value hits at this. So that will be the same as the total grouped frequency. So then to find the median, what we need to do is divide the total frequency by 2. Find the value along the cumulative frequency or the y-axis and draw a horizontal line through this value until it hits the cumulative frequency curve. At this point it hits the curve, draw a vertical line down towards the x-axis, and your median value will be the value of interception. And again, for the lower quartile and upper quartile, I will go through those steps as well. Now for less than, more than, again your steps are on the screen, but like I said, the best way of explaining through these is often to go through an example. So we're going to take the same diagram that we've drawn, and what we're going to do is we're going to use this to work out what the median, the lower quartile, the upper quartile, the IQ are less than 110 and more than 170. Now these questions are incredibly popular when it comes to high level cumulative frequency diagrams. So let's have a look at working this out. Now with the median, what we need to do is, first of all, our total frequency is 150. So to find the median, what I'm going to do is I need to find the median position, which is 150 divided by 2, which is 75. So what I then need to do is to draw a horizontal line through 75. So I'm going to find where 75 is, which is about there, and I'm going to draw a horizontal line till it hits the curve, which is just about there. And I'm just going to move mine slightly down a little bit because I think that's more, it's not going to let me. And then what we then need to do, as soon as it hits the curve, I'm then going to draw a vertical line. So let's just correct that, and then I'll get the line again. And what we're going to do now is, you can see it's just about there, and what I'm going to do is connect those up. Now again, yours is going to be a whole lot easier rather than using this on the computer. And you can see there that my median value is about 138, I would say. So here we've got 138. Now to find the lower quartile, so let's just use a different colour, which I'm going to do in green. So for B, the lower quartile, what I'm going to do is I'm going to divide the total frequency, so 150 divided by 4, which is going to give me half of 75, which is 37.5. So what I'm going to do is I'm now going to draw a horizontal line through 37.5. Now again, it's going to be quite tough, but what you want to do is just do it to the best of your ability on the graph. So I'm going to say roughly it's about there, which is coming up as 40, so let me just move that down slightly, if it lets me. No, it don't. And then what we're then going to do is draw another horizontal line, a vertical line through that. So once it's a curve, we're going to go upwards like so. And it's going to let me. No, so I'm going to draw it freehand. So what we've got is this point here is at 37.5. And let me just get rid of that because that's clearly at 40. And so 37.5, I'm just going to use a dotted line like so, and then as soon as it hits the curve I'm going to project downwards, and we're looking at about 126, I would say. So from this, so I've got 126, and then to find the upper quartile, which I'll do in blue, so the upper quartile, let's use the thicker pen. So the upper quartile, which is basically going to be 3/4 times 150, which is going to give me 107.5. I think that's right, yeah. And then, oh no, 112.5 rather. Thought it looked a bit odd. And then from this, what we're then going to do is now draw a horizontal line at 112.5. So I'm going to take a wild pop at it being somewhere around there. And again, you would be definitely using a ruler for this. And as soon as it hits the curve, you're then going to project downwards. Again, mine's definitely not straight, but yours would be because you're using a ruler. And we get 148. Now from this, what we can then do is work out what the interquartile range is. So let's pick a colour we've not used. Let's go for orange. So for D, the interquartile range is going to be the upper quartile, which is 148, minus the lower quartile, which is 126, giving me a IQR of 22. Now when working with less than values, this one's slightly different. Now let me just quickly write down the answer to the interquartile range, just so in case I'm rubbing all out. Now for less than values of 110, what we need to do is we actually need to work out the frequencies. Now for this, we kind of need to go in the opposite direction. So for this, what we're going to do is we're going to find 110 along the x-axis where it's got the length. And what I'm going to do is I'm going to draw a vertical line going upwards, and then as soon as it hits the curve, I'm then going to project horizontally to tell me what my value is, and the answer would be this number here. So I reckon roughly it's about 13. So I'm just going to write equals 13. Now for more than 170, now this is where it takes a little bit of a more complicated turn. So first things first, I need to find where 170 is, which is just along that line there, which makes it nice and easy. And what I'm going to do is I'm going to draw my vertical line up until it hits my cumulative frequency curve. And let's just continue that. And as soon as it does, I'm then going to scroll across. And we get the answer of 140. Now the question is that if you use an element of common sense, we've got 150 leaves, and the question is asking how many are more than 170. Now clearly the answer is not going to be 140, because you can see that the average was around about 140. So more than 170, it's definitely going to be less than the 50% value. Now for this, what we need to do is, we know that, let's get the orange pen back again. So for F, what we need to do is, here, we know that there are, from this, we've got 140 leaves are less than 170, which therefore means that 150 minus 140 equals 10 leaves are more than 170. So what we've got here is that this value here is our total, our grand total of leaves, and this is the number that is what we've read from the graph, which is 140 rather. So when you're reading numbers from your cumulative frequency diagram by going up from your x-axis to the curve and then going vertically across, that number there would always be the number that's less than whatever your x value is going to be, which is quite confusing, particularly when you're saying it out loud, but hopefully that does make sense in terms of working it out. So you kind of just got to use an element of common sense and know when to go up and then across, and when to go across and then down. When you're working with the quartiles, you tend to go across and then down, and when you're trying to find frequencies that are more or less than a particular value, then you're going to go up, starting at that value, go across, and then whatever that number is, or where it hits the y-axis, that number will tell you how many are less than that number. Now the other thing is that when you're working with cumulative frequency values, you will never be able to work out the exact value. So I wouldn't be able to work out how many leaves were exactly, 140 millimeters, because it always deals with group data. In order for you to find that, you'll need to know the raw data. So you'll need to know a list, or see a list of those 150 50 leaves in length. Like I said, so that's one of the most common questions you will get asked. The next thing you could get asked at a high level is for you to then draw a box plot from a cumulative frequency diagram. Now if you remember from the previous video that in order to draw a box plot you need 5 bits of information. You need to know the minimum value, you need to know the lower quartile, you need to know the median value, you need to know the upper quartile, and you need to know the maximum value. Now from the question above, I know that the minimum value was 80 millimeters. And the highest, the longest leaf was 195 millimeters. Now in terms of the lower quartile, if I go up to the previous part, I can see that the lower quartile was 126. The median value was 138. And the upper quartile was roughly around 148. Now typically what you would do is, from your cumulative frequency diagram, is you would find out those points. So the median value was at 75, so what I'm going to do is just draw my dotted line from here till it hits the curve, and then scroll downwards as best that I can. Now what you then want to do is, if you project down, now this kind of works nicely if your scales match up exactly to your box plot scale to the one that's on your cumulative frequency diagram. Now I'm just going to get rid of these two, and that purple line represents my median. So I'm just going to write, so median is at 75. Now to work out the lower quartile, my lower quartile is at 37.5. So I'm going to find 37.5, which is about there, and I work across till it hits the curve and then project downwards. Now I can see that the projectile is going to be around about there. Now what I'm going to do is I'm just going to correct this, because you can see clearly it's gone a bit skewy, and my median value should be around about here. Let me just go from there, and 126 is about a little bit about right. So we just project those lines down. Now my upper quartile was at 112.5, so I'm going to find 112.5, and I'm going to draw a straight horizontal line till it hits the curve and then go downwards. And again, you would definitely be using a ruler for this and to find that it's about there. Now from this I also know from the data that my lowest value was at 80, So again, I can project down from there, and my highest value was at 195. So if I just quickly go from there, 195 is about there. And you can see there that I've got these sort of sections for my box and whisker diagram. So the only thing left for me to do is to draw my box, which again you should be using a ruler, and then drawing your whiskers. And there you can see you've drawn your box and whisker diagram from a cumulative frequency diagram. And again, one of the advantages of doing this, or one of the reasons for doing this, is because you can only really draw a box and whisker diagram when you've got raw data. When data is grouped, you'd have to draw a cumulative frequency diagram, find out the quartile values, and then project your graph from that data. You can then draw your box and whisker diagram. Alternatively, you could cheat and use a calculator if it allows you to work out the quartile values.